Hey, today we're gonna look at the very basic technique of developing cloud applications, and that is exponential backoff. So imagine the situation which is like very common in the cloud, where you have a client requesting some service on the internet, and that service, in order to respond to the request, it makes some request to service B, service C. Service C can make a request to service B as well in order to respond to this request. So this is a pretty typical picture on what would happen in with the customer's request in the cloud. So it's all good. It all works most of the time, but of course, no request is guaranteed to work 100% of the time. So most common cause of this would be, for example, a network hiccup. It could be like a 1-second blip when service A calls service B, for example, and is unable then to return the response. So it throws an error to client A, and like in the best case, the client application would show a notification to customer that the request could not be, basically that the service has thrown an error. Can we improve the situation? And the answer is yes. So if there are some network hiccup, in this case, what we can do is, instead of customer actively trying to repeat the request, the client application can automatically repeat the request to service A. And in this case, it might happen the network is working again, and all the requests will work, and the client will get their response. The problem with that is that I think the most naive implementation of the retries would be just like maybe sleep for 1 second and retry the request again, and every second just keep retrying service A until we get the response. So this would work, but this brings a few problems, and one of the problem could be is that the problem, for example, between service A and service B might persist for a little bit longer than a few seconds. Maybe it will last 10 seconds or 15 seconds. And usually when there is a client-server communication setup in the cloud, what the server does is it sets the rate limits to the number of requests that the client A can do, every client can do to service A. So with the most naive implementation, imagine there is a network hiccup lasting like for 10 seconds, and you just keep retrying requests from client A. When the hiccup is resolved, the service A is ready to respond to you, but you have made too many requests at this time, so instead of a good response, you get a rate limit error from service A, which is not good, of course. So one of the most common techniques used to prevent this sort of situation is called exponential backoff. In this case, this is used just to delay the subsequent shell requests from client A to service A in order to prevent situations like rate limiting, hitting the rate limits, for example. So, and today we're gonna look how the implementation of the exponential backoff could look like. So for that, I will create a service A client. So this just represents a client that sits on the customer application. So all this code is in the customer, in the client application. Let's imagine this client has a method like get data. It's a very generic method. And it returns a promise with some data response, which I will just describe as an empty interface for now, right? So usually this method would be async. Well, yeah, it'll always be asynchronous. And for now, instead of making a real HTTP request to the server, I will just throw an error. So this emulates a situation where server say, for whatever reason, could not serve your request. So let's say service unavailable, right? So my main function in this example would just call this getData method. So let's create a service, the client instance, sorry. And then I will try to get the getData, and I will await for the response, right? And for this very example, I will just send a response to the console. So let's see, in order for this to work, for await to work, I need to make the main function asynchronous. So this works now. So what happens here is that my client just always throws an error. And that's what we see now in the output, right? So as a next step, what we can do is we don't want our program to crash. So we want to catch the errors that the client might be sending. Of course, we can only do the response if we can only have the response if this call succeeds. And if it throws an error, it will go to this branch. So, right, this is where we end up with. And now, as we talked earlier, the most naive implementation would be just try it again, right? So how do we do that? What we can do here is just introduce a for loop, right? And let's say I will retry 10 times here, and see what happens then. So in this case, we just got 10 times the error. Let's modify our client, and let's emulate a situation where the getData response always returns an error for the first 5 attempts. And on the 6th attempt, it will return the correct response. In order to do this, in this implementation, this example implementation, I will just increment the attempts, and I will throw an error if attempts, let's less than 5, then I will throw an error. But if not, I will just return. There's a promise. I need to return a promise here. And let's just imagine that our response has some data in it, right? This could be hello world. So let's run our program again, and let's see what happens then. So what happens here is that for the first 1, 2, 3, 4 times, when we call the client, it returns with an error, and we end up in this branch. And since our program tries the 10 times, it will just keep requesting the client, and the rest of the attempts it will get the correct response. So in order to prevent that, once we got the response, we want to break the for loop so that we got the response, and this is where we stop, right? Think in the real world situation, you could return from a method that would fetch the data from the service. So let's see what happens now. So as expected, you got errors the first 4 times, and you get the response back. And once you got the response, you're satisfied, and you do not retry anymore. So going back to the exponential backoff idea, what we can do here is we can measure the time when you try to do your attempts, right? So what we can do is say the last attempt at would be a number of will be basically a timestamp, which in TypeScript is a number. So I don't need a constructor for this. I will just initialize it with 0, and I can say if the last attempt is greater than 0, it means we're calling this method a second time, because I will also initialize it here. So now the last attempt would contain, on the first call it will be 0, but on the second call it will be a timestamp of when the call was made. And we can, for debugging purposes, just log the time interval that was between the calls, right? So we can say last attempt at, and what we can do now is just calculate the difference between the current timestamp what we can do here is make a message a little bit nicer. Milliseconds ago. Let's see if this would work. Let's also maybe change the console error here to the log, so our output looks a little bit nicer. All right, so we do need to set the last attempt here, and here to make the output nicer, I will just output the error, so we don't get the stack trace that we don't need in this example. Okay, So what happens now is that we get in the errors, and there was no last attempt in the first call, but on the second call we see that it was 4 milliseconds that happened between the times where we call this getData method, right? And on the subsequent requests, the delay was even 0 milliseconds, and 1 millisecond. This is a situation where you can easily hit the rate limit of the real server when in the real world situation you call the real server. So the technique to avoid those rate limits is an exponential backoff. So what's the idea of the exponential backoff is that you exponentially increase the delays between your attempts to get data. So let's say on the first call you will have a delay of 1 second. The second call there will be a delay of 2 seconds, and the third there will be a delay of 4 seconds. On the fourth request there will be a delay of 8 seconds, and so on. This depends on the business logic of your application, like how much time you're willing to spend on retrying before telling the user that you failed to do the request. But this is the idea, it's just exponentially with the base, with a power of 2, you increase the delay. So how to do this is just to basically wait for the given amount of time between the retries. So waiting you can do just with the sleep function. Let me try to implement this one, the sleep function that actually would wait for the given number of milliseconds, and it will return a promise in order for you to be able to await for the sleep function. And in this case, we would need to actually instantiate a promise, and then we have a resolve, and we would only resolve this promise after the certain time passes, right? So I send this requested time of sleep to the set timeout second argument. So in this case, JavaScript engine would wait for the roughly this amount of time. It's so never precise, and it will call the resolve. So the idea here is, let's first try to just wait for 1 second between attempts, right? So before we're doing the retry, we will just wait for 1 second, right? 1 second is 1000 milliseconds. And let's try to call this function again, our program again. And you see that roughly there are 1 second between the retries, and finally on the 5th retry you get the response. So this is not an exponential backoff yet, because yes, it's good if your service allows you just to retry every second, but sometimes, especially if the service involves heavy calculations, the rate limit will be more aggressive than that, and you don't want to hit those limits. So in this case, you would need to sleep exponentially, and in order to do that, you implement, you use the math function. Just basically say this would be to the base of 2, and we would use a number of attempt as the argument. So let's see the math power. If the on the very first attempt, it will not sleep at all, right? It will be sleep 0. But on the first attempt, it will sleep for 1 second. On the second attempt, it sleep for 4 seconds, and so on. So let's try and see what happens. Yeah, this roughly seems to be working, but let's see. First of all, we want to wait for seconds and not milliseconds, so I will multiply this by 1000. And another thing for easier debug, let's add some output to here. So sleeping for milliseconds. And let's run it again. Now you see that after the first attempt we sleep for 0 milliseconds, and the last attempt was 6 milliseconds ago, sleeping for 1 second, and there is roughly 1 second between the calls, sleeping for 4 seconds, and so on. So why other attempts do not follow this pattern? They follow another pattern. This will be 0, 1, then 3 to the power of 9. Oh, sorry, 2 to the power of 2 is 4, 3 to the power of 2 is 9, 4 to the power of 2 is 16. Yeah, so this would be the correct row on which we can be waiting. So let's just try and see if the next two attempts will be 16 and 25 seconds. And for this, I will throw an error in after 7 for the 7 first attempts. So this immediate retry, it can be a problem. So if you don't want the first retry to be immediate, what you can do is just increment I by 1 when you are calculating the sleep interval, right? So yeah, and indeed, this is what the delays, the subsequent delays look like. So 0, 1, 4, 9, 16, and the next one will be 25. So if you don't want the immediate delay, you just increment the I by 1 here, and let's see what happens then. So as you see, the very first time we got an error from the service, we sleep for 1 second before doing the retry.